succeed. हाँ जी, होपफुली अभी तक तो समझ में आ रही है अभी तक, राइट? यू स्टिल हैव क्लैरिटी, राइट? अभी तक तो है ना क्लैरिटी, क्या पढ़ रहे हैं हम?
हाँ जी।
ठीक है। ऑलराइट, तो आज हम थोड़ा सा ना वी विल टच अपॉन कोलिजन, ऑल्दो आई एम श्योर स्कूल में पढ़ाया नहीं होगा क्योंकि वो एनर्जी के चैप्टर के बाद इट मेक्स मोर सेंस, द टॉपिक ऑफ कोलिजन, जहाँ पे हम कोफिशिएंट ऑफ रेस्टिट्यूशन के बारे में, लाइक यू सेड वो दोनों चिपक जाएंगी बॉल, वो स्कूल में पढ़ाया था आपको?
नहीं तो मैंने ऐसे एग्जांपल दे दिया।
ओके, ओके, नो प्रॉब्लम, बट आई टेल यू बिकॉज यू आर प्रिपेयरिंग फॉर जेई, एंड मैं जो सरदाना हमारे जो हैं उसी से आई विल आस्क यू टू प्रैक्टिस, ओके? तो लेट्स गो एंड सी द कोएफिशिएंट। आई जस्ट इंट्रोड्यूस यू क्योंकि ये तभी कर पाओगे जब आप when you're trained on energy also a bit. आसान होता है, मुश्किल तो कुछ भी नहीं है, खैर you will understand still now I'm sure. So let's talk about the concept of coefficient of restitution. Okay? Broadly जो आपके लेवल के लिए जो हमें सीखना है ये E, right? Topic is when two bodies collide. पहली बात तो types of collision क्या है? Two types of collisions are there. I yesterday told you. One is a head-on collision where the centers coincide. ये आपके सिलेबस में स्ट्रेट फॉरवर्ड होता है, राइट? द सेकेंड टाइप ऑफ कोलिजन इज व्हेन द सेंटर्स डोंट कोलाइड, ओके? नाउ दे कोलाइड लाइक दिस but their centers are not aligned, okay? There is a gap between them. This is called as an oblique collision, okay? और ये आपका हेड ऑन बिल्कुल लीनियर कोलिजन है। तो कोलिजन जब हम बात करते हैं, एक तो हमने पढ़ लिया लॉ ऑफ कंजर्वेशन ऑफ मोमेंटम, जिसके अंदर सिंपल सी बात थी, इफ यू हैव अ सिस्टम एंड द सिस्टम हैज न्यूमरस bodies of masses m1, m2, m3, m4, they are colliding between themselves, any number of bodies, and there is an absence of external force. The sum of the momentum will remain conserved even after when they collide. So if this is the initial part, this will remain conserved. So this is your final. Although they will keep on exchanging momentum among themselves, but since this overall system has no external force, you can put any number of masses, they keep on colliding. You cannot change the momentum, which means the net external force on the system is zero. So here also you see a bit of collision in the chapter of law of conservation of linear momentum, जो हमने x axis और xy दोनों में पढ़ लिया। लेकिन collision जो एक special attention इसलिए draw करता है क्योंकि collision के concept में there is an extra element of kinetic energy that gets introduced, which is when two bodies collide. Obviously, if there is no external force and they're colliding like this, then, and we're not actually getting into details of oblique collision. I'm saying the two bodies collide head on. They exchange momentum between themselves. After the collision, they may go in the same direction. They may decide, collision happens in a way that they go in the opposite direction. It depends on many things, right? But broadly, we are assuming a head-on collision, which can be a body, two bodies moving in the same direction and colliding, two bodies moving in opposite direction and colliding. For us, the law of conservation momentum only changes to the extent that this one will have a negative momentum and this will have a positive momentum because it is rightward, this is leftward. So its initial momentum will be negative from the sign convention. That's all we are worried about. Now, because they're colliding, there are three ways bodies collide. And why suddenly this introduction of three ways? It is because of an extra element of kinetic energy. Now, if the kinetic energy remains conserved, so one, momentum is conserved, right? It is a constant of the system. The momentum is conserved. P represents momentum. It is a K. K means constant. Now what happens is, assume a situation when the energy also remains conserved. So situation number one, kinetic energy of the system remains same, which means there are collisions in which kinetic energy will not remain same. The systems in which momentum and kinetic energy remain conserved are called as elastic collisions. So you have collisions which are happening with no loss of energy whatsoever, which is kinetic energy. The label is elastic collision. Straightforward, both are conserved. P anyway is conserved in any type of collision we will talk about. Second type of collision is inelastic collision. Okay. If you refer to an inelastic collision, will the momentum remain conserved? Yes, because there is no external force. But the kinetic energy will get lost in sound. When the two bodies collide, there is a sound, and heat also gets generated, right? So energy gets transformed into heat, and sound gets lost. So after the two bodies part ways, after colliding, the kinetic energy of the system has reduced, which means the kinetic energy of the final system is less than the kinetic energy of the initial. So this will, we call it broadly a inelastic collision, and which is what real life is all about, inelastic collisions. The third case is called as a superelastic collision. Okay. So now the two bodies collide, but they collide in a manner that momentum is still conserved, obviously, because there is no loss of momentum, there is no gain in momentum, there is no external force, acceleration or deceleration, nothing. However, the kinetic energy of the final system becomes greater than the kinetic energy of the initial system. Like we studied yesterday, if you have a bomb which explodes, although the momentum of the two particles individually was conserved, 1 by 4 m and 3 by 4 m, they went to their respective sides. Initial momentum was 0, and I said there is an external force which has generated. A lot of students have confusion. There was but it is an internal force, and therefore it does not impact the zero existence of momentum before or after the collision. It remains 0 only. Even after the collision, for a moment, the bomb is at 0 momentum, and then of course you can apply the rule of m1 v1 plus m2 v2 is equal to 0. However, now because of the collision and chemical energy having got released from the bomb, the kinetic energy of these two particles, if you add them, it will be greater than the initial kinetic energy, which is obviously it was at rest because the momentum was 0. So this is the case where the situation of super elastic collision, this is referred to super elastic because the energy has increased, right? So from energy standpoint of view, there is an addition because of the transformation of chemical energy into mechanical energy. When I say mechanical energy currently, because you have not studied, generally we will use mechanical energy word, and it will include the potential energy due to your position from the surface of the earth plus your kinetic energy. These are the two energies which are included in the definition of mechanical energy. So this chemical energy, because of explosion, converted into only kinetic energy. And of course, if the particles after the the explosion, they travel like this and this, three particles, right? Then if you can of course apply the law of conservation of momentum again, but this time you will apply in m1, m2, m3 in 2 dimensions, which means you will do a py separate net does not remain, sorry, it remains constant, and you will do the same thing in x-axis. You will divide the velocity into x and y, or you can write the whole thing. These angles will be known to you, right? This could be alpha, this could be beta. You will resolve this velocity, multiply by m, the x component, you will add all the x components and say these are all 0 because initially it is at rest. And then you will calculate the final momentum after the collision, which also will be 0, but it will be done vectorially. So you can have a situation where a bomb explodes, moves to the right and the left, but it can also move like this. It depends what is given in the question. So 3 types of collisions you have to know, at least in your mind, that these are the ways. And now what has happened is the concept of coefficient of restitution. Okay, so coefficient of restitution. Okay, I have many videos on my YouTube channel already where I've explained this. For your purpose, it is called as E. It is known as E and is given by negative of relative velocity of separation. Okay. Sorry, if you write velocity, relative velocity of separation, you don't need to write it. So after the collision, the two bodies go like this. Right? This is 5 meter per second and this is 3 meter per second. If you calculate the relative velocity of these, with respect to each other, it is 8 meter per second on this side, and as seen by this, -3 -5 is equal to -8 meter per second. So on the numerator, you will write and I will show you how is it linked to elastic collision or not. So relative velocity of separation divided by relative velocity of approach. So the two bodies can approach each other, say they're approaching, and this can also be an approach before the collision, right? So here the velocity is 2 meter per second, 3 meter per second. The relative velocity is 5 meter per second. If I just talk about the magnitude, and if this is 2 meter per second, this is 3 meter per second, they're still approaching, though not at each other in the same direction. Say this is 3 meter per second, this is 2. Relative velocity is 1 meter per second, magnitude wise, right? So you can put the values of relative velocity of approach and in the denominator, and after the collision, the two bodies then move in a certain way. Maybe they move in the same direction, opposite direction. This body is at 1 meter per second. This is at 1 meter per second. The relative velocity is 2 meter per second. Now, E, which is the coefficient of restitution, right, is actually division of two relative velocities. One, the relative velocity of separation divided by relative velocity of approach. And the magnitude of this, if you write it in terms of velocity exactly, then V2 minus V1, this is the velocity of the second body minus the velocity of the first body after the collision, and then divided by U1 minus U2. This is the way you will calculate this value. And if you want to write it correctly, then it is minus of V1 minus V2. I'm giving relative word algebra, right? So just calculate U1 minus U2 and V1 minus U2 and put a negative sign. That's your coefficient of restitution. Now, why did we study the coefficient of restitution? For the simple reason that if you solve all of this and your value of E, the numerical value of this ratio, if you do that, and we're not getting into any derivations out here, for a perfectly elastic collision, which means the kinetic energy also remain conserved, the momentum also remain conserved, E is equal to 1, right? Which means I can write minus of V1 minus V2 upon U2 minus U1 minus U2 is equal to 1. I can easily write this. And even if you do a derivation of the law of conservation of momentum with the help of the kinetic energy equation, before collision and after collision, you can write the equations, which we will later, and compare, and also do another algebra of conservation of momentum. These two, when they are solved and you find the values of V1 and V2 after the collision, put those values here, you will get the answer as 1, which means the kinetic energy was conserved. This will also give you some V1 square plus V2 square plus equal to half M1 U1 square plus half M1 U2 square. The kinetic energy before the collision and after the collision. So you will solve these two for final velocities, and final velocity expression will come. V1 is equal to so and so, and V2 is equal to so and so in terms of masses. And this will be U1 plus a bracket and a U2. So in terms of initial conditions, so this will be a mass into U2. If you put these values here, you will get a value of 1. So coefficient of restitution is basically a representation of the type of collision. Right? If it's a collision which is 100% elastic, 100% elastic, you will say the E for this collision is 1, and it shortens your work. You don't have to get into detail. If you see that the question says the collision is 100% elastic, you straight away can use this expression to calculate the velocity. So one, of course, you are going to use the law, if they're asking about velocities, right? If they're asking you the complete momentum conservation and all that, still this expression holds good because your momentum is still conserved in this, in a 100% elastic collision. But when we will do this, when we complete the chapter of kinetic energy, work power energy, but in along with linear momentum, it is conservation. It is important to understand the concept of coefficient of restitution also. Generally, you will find most of the scenarios, you will have the coefficient of restitution residing between 0 and 1. This is a general representation which you must know about. Any doubts in your mind so far? It's a dimensionless quantity because it's a ratio of two relative velocities. There is nothing, right? And if you get an E equal to 0.25, you're essentially saying it's an inelastic collision. There was a loss of energy. There was.
ये सब डायनामिक्स में ही आता है.
हाँ, आता है. ठीक है? Very important. I mean, at this stage, just awareness is good enough that an extra element has got a special case of linear momentum conservation has come up where the energy remains conserved, energy does not remain conserved, energy increases also, which is a superelastic collision, and all these scenarios can be expressed by way of a mathematical quantity called as E, which when you do the derivation can be expressed as this quantity. You can just memorize this for a while. That what is a coefficient of restitution? It's a after the collision, the relative velocity of separation divided by relative velocity of approach. Now let me come back to one with the head-on collision part, okay? And this is important. Head-on collision. Yesterday we did some numericals, but you will get a question in your school, which everybody does, is the derivation, okay? And the derivation would look like this. These are the two bodies and they are moving in U1 and U2. They collide, and after the collision, their velocities become V1 and V2. They collide. Sorry, I think the masses are different. And when you write the complete equation, because we are still studying collision here, head-on collision, what you will get is this. And how? You will apply law of conservation of kinetic energy remained conserved. So we're talking about an elastic head-on collision. Kinetic energy remained conserved. The momentum also remained conserved. Delta kinetic energy is 0 and delta P is equal to 0. The expression that you have to remember is V1, which I was telling you is part of the derivation, is M1 minus M2 upon M1 plus M2 into U1. Okay? Plus 2 M1 upon M1 plus M2 into U2. And this is a vector. Okay? So you can find the value of your final velocity because you know the masses, you know the initial velocities straight away using this formula, which comes from the derivation of kinetic energy remaining conserved and the momentum remaining conserved. You can straight away find it. And then in similar way, you can find V2. This will be the reverse of what we have written. So 2m1 will come here. Oh, sorry, this is going to be 2m2. 2m1, m1 plus m2 into u1 plus m1 minus m2 upon m1 plus m2. Okay, so you can see the symmetry of the equation. So in this u2 comes with, this is m1 only. Okay, so this is u2. What was coefficient of u1 is now the coefficient of u2 for v2. So this is also additional extra knowledge you can have for JEE under the topic of collision, which is a special case of law of conservation of linear momentum with an additional study of what's happening to kinetic energy as part of the discussion. Any questions in your mind?
No, sir.
Okay. So so you can have various cases, right, which your ma'am told you, I think, as a passing remark. Now, your mass, for example, is very large as compared to the second mass. So this is a case of a wall. This is your wall, and you send a small body to it. So this is M1, which is 5 kg, 10 kg, 80 kg. A wall is infinite mass. So if you put one of the masses as an infinite mass, and you say, okay, I'm going with u1 velocity, my u2 is 0, it's a wall. You can't have a u2 in the wall. So these two are anyway out of equation. Let's calculate what happens to, and of course a wall will not have any final velocity. Only this ball will have a final velocity. So final velocity v1 is equal to, and m2 is infinite, right? And therefore, if I just write as m1 divided by m2 minus 1 upon m1 upon m2 plus 1. Okay, so in the denominator it's m1 plus m2. Now this m2 is very large. This m2 is very large. So your v1 actually comes out to be, this becomes 0 because it is being divided by infinity, and there is a u1, right? So this is also infinity. You're left with u1 multiplied by minus 1, which means you will collide and come back with the same velocity. So your final velocity will be reverse of what you were. Small sample conclusion for you. A wall is an infinite large body. So you can have multiple situations and say, okay, billiards ball, both the masses are same. Put the value. So you will get v1 for a billiards ball of equal mass colliding, right? And you know the initial velocities. You can put the vector sign also. If you want to write in I, J, K or minus 10, plus 10, depending on sign convention, just put it. If you put it, you will get 0 here. u1 plus twice of the mass upon 2m again, because the masses are same, into u2. Okay, so v, the final velocity of the first ball, is equal to u2. So whatever was this mass, it had u1, this is u2. After the collision, you're talking about v1 and v2. These are the two you're talking about. You're saying my first velocity of after the collision, this velocity is this velocity now, which means there is a exchange. This body came, it collided with this particular body. Now it acquired the velocity v1, whose magnitude is this, and vice versa. If you want to find the velocity of this body after the collision, put it here. You will get it as u1. The exchange of velocity happens in this case. Velocity gets exchanged if they're equal. So you can, if you know this general expression of v1 and v2 for a 100% elastic collision, and there is a derivation which will come later in your syllabus, not now. When you do work power energy, I'm sure you will be taught the collision in your school also, right? So you can have any cases. The mass was double, mass was this, very large, etc., etc. You can always do that. Tell me if you have any doubts in your mind. It's a new thing, but it's very useful. And then you can say, my first body was at rest. What will happen? Put u1 is equal to 0. If you were having a collision where your first billiards ball was at rest, and the second billiards ball has come and hit it with a velocity of 5 meters per second, and u1 is equal to 0, u2 is equal to 0. Both are of equal masses. The first billiards ball is at rest, which means its velocity is 0. Come and strike it and put the values here because they're of equal velocity. Your u1 is 0. This will go away. This will go away. And then let's see after the collision what happens to the ball which was stationary. This component is 0. Put the value here. Put the value here. You will get a value into u2, which means this body will acquire the velocity of this body. This will come to a standstill, this one, and the stationary body will start moving with a velocity of 5 meters. Again, exchange of velocity. The red ball now becomes stationary, and the white ball starts moving with the same velocity as the red ball. Okay, so you will be asked these questions in JEE mains and all that. We will study this in depth along with the chapter of work power energy. But for the time being, this is good to go. So just a quick revision. We have introduced that there is a collision. In a collision, we not only study momentum, we also study kinetic energy conservation. Sometimes the kinetic energy is not conserved. Those collisions are inelastic collision, and generally the energy loss is there in the form of sound and heat. Therefore, the final kinetic energy is always less than the initial kinetic energy. Momentum will remain conserved in all these collisions because there is no external force. Superelastic is like a bomb example where the kinetic energy is actually coming into the system from the chemical energy. And then, of course, how do we, express all of these mathematically. So there is a derivation and a representation called as coefficient of restitution. It has a lot of detail behind it, but that theory is out of our scope for the timing. Simply speaking, it's a ratio of relative velocity of separation and approach. If the value of E is equal to 1, then that collision has kinetic energy conservation applied to it, saved, 100% saved, and the momentum anyway is saved. If generally we say there is a loss of energy in most of them, inelastic collision, this is an inelastic collision. And of course, in a superelastic collision, you can also get it greater than 1. Don't worry about it. They don't ask you too much. All right. And then, of course, we studied for a head-on collision, if we have to actually find the values of velocities after the collision, momentum conservation and kinetic energy conservation, both equations solved for V1 and V2 after the collision, there is a simple expression available. And then we studied different cases like a wall, infinite. You know, if you throw something on the wall, it comes back. Assuming that when it strikes, strikes here, there is no loss of energy. There is nothing, right? There is no deformation also, right? Which is like an impulse kind of force. When a bat also hits a ball, there is a deformation. There is an impulse, which is small amount of short duration force that will deform the ball, which means the ball will no longer circular, but will show some deformity. But anyway, so there are details to the concept of restitution, which you're not worried about. These two equations are also very, very important. The equations of velocity, the V1 velocity and V2 velocity. And then we took the example of billiards ball. Good to go? Any doubts in your mind? Okay, all right. Now, very importantly, this is in your syllabus now, and yesterday which is the concept of kinetic friction and the concept of static friction. All right. So my question to you, since you had no clue about collisions, I had to speak most of the time, and I will draw some diagrams now, but I'll start with a simple diagram. All right. So the gravity is 5 so if this is 5 kgs, this is 49 Newton. It gets pushed back by the ground with a 49 Newton force, action and reaction pair. This is your normal reaction. And then let's introduce the concept of friction, which we did a bit. There is a roughness always available on the surfaces, right? So, and there is a roughness, and therefore the so-called the grains of wood, or at the atomic level, there is a traction, and the surface is never smooth, right? It is like this. And if you keep a block also on top of it, still the block also has something like this. And therefore, when you try to move the block, these teeth which you see, which are the imperfections, it's not a polished surface. It appears to be polished, but nothing in this world is as polished. Even if you have your dining table, you throw something like a book, it will finally slide and stop, even your floor. So there is an existence of a force which comes into play to oppose the motion because of something called as friction, which exists only between two surfaces. A single surface has nothing called as friction. Unless you touch it, it will not have any, you can't feel it. The only way to feel a frictional force is to be able to make two surfaces in contact with each other. Okay. So if you try to slide this block over this block, a frictional force will oppose this motion, right? It has to oppose. If you move this block on this side, the frictional force will come on this side. It will oppose because of the grains which are getting interlocked at this place. They're getting, similarly, if you have an inclined plane, which is some sort of machine or a, it converts the potential energy at the height, and you come sliding fast with kinetic energy. So the energy has got transformed from potential energy to kinetic energy, and you will fall with a great force here, right, at this point. Now, here also,
इतना पता नहीं है मुझे
क्या?
Potential energy के बारे में.
Okay, so potential energy, you don't need to know. It is the energy because of the height. The
सर ये वर्क पावर में है सर।
work power mein. But I keep on throwing the words to introduce you. I'm not teaching you potential energy at all. My whole focus is kinetic energy. But in the middle, I do introduce some new words for you because I know it's a bit handy to understand from other points of view also, which is energy standpoint. Why does a body? Why? So forget if you don't understand. If there is a frictional force here, the body has g sine theta. You know this now, right? But if the tendency is to go down, it will try to oppose. The frictional force will come and will try to oppose. If it is not sufficient, the body will go down with g sine theta minus f as the net force. If it's a absolutely smooth surface, remove this. But if the body is not able to, this is far greater than the frictional force that comes, it will go away. So I have used the word kinetic and static friction, but before that, we're just warming up to the understanding of there is a force which appears because of the two surfaces being in touch with each other. There is nothing called as a smooth surface interaction. There is nothing like that. A force does appear. Now, there are two types of frictions we will talk about. One is the static friction. All right. Now, if you talk about static friction, it looks like this. In real life, how do you feel something like static friction, right? So this is your block. What you do is you push the block with 1 Newton force. It does not move. But a frictional force to oppose this also comes into play of 1 Newton. Then you push it with 2 Newtons. A frictional force of 2 Newton appears because it did not move. But why it did not move? Because there is a frictional force. Then you increase the force and you continuously increase the force. At a certain force of, for example, 15 Newtons, this body started moving a bit. Moving a bit. At that point, what you overcame till that point was the static friction. The friction that exists till the point the body starts moving. So you keep on increasing your external force. The frictional force will keep on adjusting itself. The adjusting frictional force, which is just before the motion, is the highest static friction available, which means the static friction is a self-adjusting friction. You apply X Newton, it will also become X Newton. But if X Newton crosses a certain point, then the body starts moving. When the body starts moving, it still has a friction acting on it, but that friction is called as kinetic friction. But this is not self-adjusting. The kinetic friction is constant between the two surfaces. It has nothing to do with self-adjustment. So this is what will happen. You if you draw a diagram and you say, okay, let's do. So initially you will keep on increasing your external force. The static friction will go up. At a certain tipping point, when you overreach this particular external force and a self-adjusting static friction, suddenly you will see that the body has started moving, but the value of friction will goes down. So what you notice in reality is that static friction value in Newton's static frictional force is greater than the kinetic frictional force. There are ways to calculate both of them. This is self-adjusting in nature. Self-adjusting in nature. It purely depends on how much external force you have applied on it. This is more like in a photoelectric effect, you keep on applying different frequencies. At a particular frequency, the electron comes out. So threshold, when you approach your threshold friction, you will start moving and you will see that your frictional force has become sort of constant at that point of time. Okay, so let's see an example. What is happening here of the static friction, and this happens. Some people try to push, a block. They know the mass is m. So mg, they can draw a free body diagram. This is normal reaction. They push it with F, a frictional force appears F. They push it with 2F, it becomes 2F. They push it with 3F, this becomes 3F, and then they reach the threshold. Now, frictional force, the static frictional force, what is the algebra? Is proportional to the normal reaction. Which means the greater is the normal reaction coming from the earth, greater will be this frictional force. This frictional force, which is horizontal, which is opposing this external force, adjusting itself as per the external force, is proportional to normal reaction. And now frictional force is equal to mu s multiplied by the normal reaction. This is called as coefficient of static friction. Okay, and when I write the value, remember I am writing the highest value of the frictional force. And you can have lesser static frictional force than this. What I have written right now is the threshold value. You are more than welcome to have a lesser external force, and all these values will also come. What we are studying now is the algebra of the threshold, where we find what is the maximum static friction this block can tolerate, after which it will start moving and get into the zone of kinetic friction. We're studying a zone which is keeping the body stationary and static, and we're saying what is the maximum static frictional force I can experience for this particular block. I keep on increasing my force and I reach a certain point and the body starts moving. I note down that force with the help of a spring balance. I have a spring balance with me which is connected here, and I'm able to measure that with the help of a spring balance. It's connected and I'm able to see some reading, and I say, okay, I applied 20 Newton when this block started moving. Maybe I'm pulling the block, okay, and the friction is acting here. First I applied 10 Newton, nothing happened. So I knew this is 10 Newton. Then I made 15 Newton using my hand here. This also became 15 Newton. Then suddenly when I reached 20, which is my threshold, and which is what I'm studying here, the threshold, okay, the maximum I can have, this started moving. Immediately I crossed the figure of 20. The figure of 20, which is the maximum frictional force possible when the body is stationary, is proportional to the normal reaction to the body coming from the earth, and is equal to mu s into n. So if the maximum frictional force which it could tolerate and still stay stationary is 20 newtons, this is n, it was 5 kgs, so 5 into 10 is equal to 50 newtons. 20 is equal to mu s into 50. Mu s is equal to 20 by 50 is equal to 0.4. So your coefficient of static friction is 4 by 10, which tells you for 4 by 10. So it tells you 2 by 5. It tells you for every 5 Newton of force, right? In the denominator, if you notice, sorry, for if you have a normal reaction of 5, the maximum force which is required to move it is 2 newtons. Because in the denominator, I have written the normal reaction. It's a ratio actually. Okay, so if you have 50, it will become 20. But beyond 20, things will change. It will start moving. And I told you the kinetic friction, although the formula is again same, the kinetic friction is proportional to normal reaction again, but this time the constant of proportionality is mu k n. And mu k, which is the kinetic coefficient of friction, is less than the static coefficient of friction for the same two surfaces. If you have a wood and a block of wood on top of it, till the time you were not able to move it, you were in this zone. And you were using coefficient of static friction between the two surfaces. The moment you have overcome the threshold, you started moving. At 21 newtons, you will notice that the force of friction, which is there, will drop below 20. Which means that it will drop below the static friction. But now you brought it in motion. The reason is kinetic friction is less than the maximum static friction. It is not adjusting. It only depends on what is the mu k of the two surfaces involved. So mu static of these two surfaces could be 0.3, but the mu kinetic will be 0.2. Now you have started moving, which means you will have acceleration or deceleration or whatever. So you have this block, you apply a force of 50 newtons on it. The coefficient of kinetic friction is given to be 0.2. The coefficient of static is given to be 0.3. This is your external force. The normal reaction being experienced is, say, 10 newtons. Let's do a calculation whether the body will move or not. First, let me find out the threshold static friction which is available to me. So it will be 0.3 because this is mu s into 10. Only 3 newtons is the static friction. And what am I supplying it? 50. I will be able to overcome this easily, which means now I don't have to worry about this maximum static friction. I just need to worry about a free body diagram, which is for a body which is moving, because we have already overcome the maximum static friction available. And if you notice, the frictional force which will come is now 0.2 into 10, because that is what the kinetic friction is all about. So 2, so you are net external force on you is 48 Newton. You are 10 Newton, your mg. So 10 into A, and your acceleration is 4.8. So you have to be careful while selecting the kinetic. If it's a stationary situation, please check whether or not the body will remain stationary. Always calculate the value of static friction, the maximum one, which is after which the body starts moving. If it does, if your external force is more than the threshold value, then like in photoelectric effect, the electron comes out. Similarly, 50 was greater than 3, and therefore this had to move. It had no choice. So now it will move. However, when you apply the second law of Newton on this, please do not write F external as 50 Newton minus static force. No. Static frictional force is finished. You have already started moving. Therefore, 50 minus the kinetic frictional force is equal to M into A, because you started moving. You only worry about this friction when you're not moving. For example, if you're on an inclined plane and it looks like this, the G sine theta you calculated as, it was given to be 45 degrees or 30 degrees, 10 into sine of 45. So this is 1 by root 2 is equal to 5 root 2 is equal to 5 into 1.732 is equal to 8.66 Newton. Right? So you know the body is being subjected to 8.66 Newton force. It is also known to you that the normal reaction on the body is maybe 15 newtons. Okay, so we can always calculate that from mg, and this is also known to us. This we have already calculated. So this is g cos theta is equal to n is equal to 10 into cos of 45 is equal to 10 upon root 2, again 8.66 Newton. This is your normal reaction. Now you calculate, it is given to you mu static between the two surfaces 0.4, but the mu kinetic is 0.35. Now you have to think whether this will go down or not. So let's calculate the maximum value of static friction available to us. So F max static which is available to us is 0.4 multiplied by 8.66. So this will be around, say, 9 into 4, around 3 newtons. This is the maximum force available to me to prevent the motion, which is in play. But if you notice, I have already applied 8.66 Newton. This is gone. We are already in motion. And therefore, to calculate the frictional force, I will use mu k into n. So mu k is already known to me as 0.35 multiplied by the normal reaction of 8.66. I will subtract these two. 8.66 minus 0.35 into 8.66 is equal to 0.65 into 8 is the net force on the body, and I can calculate the acceleration. Questions on the nature of kinetic friction and the static friction? What comes to your mind? I will give you a problem now, which we will solve together, but please feel free to ask any question in your mind.
सर कोई पुली से रिलेटेड कोई एग्जांपल है?
Yeah, you can always do that, right? The combination of multiple forces is, if you have, for example, you have, let's say, you have a situation of an inclined
टेंशन भी लग रही है.
You can do that. That is just an external force, right? Which will help you to calculate the value of external force. But okay, so let's say this is a body which is 5 kgs. So this, and the angle is also known to you to be 60 degrees. And then this is your inclined plane. And there is a special condition. This block of mass is touching the surface of the inclined plane. So the inclined plane, obviously, on the front side will look something like this, right? And the block is touching this here. So they are in contact. It is given to you that the static frictional force between them is not force, the coefficient is 0.5, very high, and the kinetic friction between them is 0.35, okay, between the two surfaces. Now this is 5 kg and this is 1 kg. The question is, what will happen now? There is a possibility when these two are touching, okay, there is a frictional force between them. On this body, if you assume that the block goes, the system goes downward, you assume that. First, you don't know. First, let's calculate what's happening. Now, if 1 kg block is touching the vertically the block, tell me what's a normal reaction available to you?
So normal
Is it
reaction
touching?
to,
It is touching. There is no push, pressing.
so normal reaction I guess would be the tension.
No, the normal reaction is between the two surfaces, right? So surface number 1 and surface number 2. It should be like this, right? The block should be pressing the inclined plane's surface, and the inclined plane should in return press the mass. If I'm just hanging it, where is the pressing force coming from? It does not exist, right?
Okay.
There is no pressing force. But I give you a pressing force. I'm saying I am pressing this with a force of 5 newtons. This is given in the question. Now tell me what is the normal reaction on the block. If I'm pressing the block with a 5 Newton force, then what is the force with which the inclined plane is getting pushed here? Horizontally. Generally, you see normal reaction to be a situation of ground, right? So mg and n. And here also you can see it is perpendicular to the new coordinate system, mg cos theta and normal reaction. Now, this particular situation, this is vertical, this is angular, but here if you notice it is horizontal. You press it with 5 newtons, the inclined plane surface will push you back with a 5 Newton force. So the normal reaction on you will become 5 newtons, which is the block. The inclined plane is experiencing 5 newtons coming from the, and say we have fixed it, it can't move. Inclined plane can't move. So forget your 5 newtons, which is coming from the pressing on the block, makes no difference at all. But the block in turn is getting a force from the inclined plane, right, which is 5 newtons on this direction. What is a frictional force? Assume, what will you do first? The first reaction will be, let me calculate the maximum static frictional force, right? Let's calculate that. And the weight of the block is 1. So we know 0.5 into the normal reaction, which is 5 Newton. 2.5 Newton is available to you. That's all. If you draw a free body diagram here, okay, this is tension, this is 10 newtons, and if you assume it moved, then you can't use this. You have to use this in the equation. But first you have to decide what is to be used. If you're able to decide that the external forces are greater than the force available, which is 2.5 Newton, this will move. You can already see this is 10 Newton, right? And if this force, so 10 minus T, which is upward force, if it is less than 2.5, so 10 minus T is less than 2.5, and therefore 2.5 is greater than 10 minus T, and T is greater than 10 minus 2.5. If the tension in the strings exceeds 7.5 Newton, only then the system will move.
Okay, sir.
Okay, but this was a way too complicated because it's horizontal. Assume a very simple situation, which is this inclined plane, and you have a pulley, and this is your. So the question says the kinetic friction is available to you as 0.3. This is G sine theta. This is, sorry, this is not G sine theta. This is G sine theta is one of the forces acting on it. This is mg sine theta, and then this is tension. In the question, it is mentioned that this system moves. And in the question, you're given two frictions again, coefficients. Choose this one because it said it is already in motion. How will you solve this? So this is your 5 kg, this is your 10 kg, and this is mg sine theta. You know the free body diagram for this will look like this. It is experiencing, there is no normal reaction on this. You're not pressing it, you're not touching it to the ground. Only normal reaction will come when the two surfaces are in contact with each other. Otherwise, you can't have a normal reaction. So mg and this is t. If I write the, I assume this will go down.
पहले हम static friction निकाल लें.
No, I'm saying it is given in the question, it moves.
Oh,
So you will not use this. There can be one part, right? What was the maximum frictional force available? Was available. You can say then it is 0.4 multiply the normal reaction.
पर ये आपने static बता रखा है μs.
Yeah, yes. So that is the maximum possible, right? If it doesn't move. Maximum is when it doesn't move. So you will say, okay, 0.4 multiply by, the mass is 5 into 9.8 is equal to 49 into 0.4, whatever. Newtons is the maximum static frictional force I have available. Maximum. Let's talk about the situation when it moves. If you assume it is moving downward, the frictional force will come here, which will be mu n. Right? So let's write the equation. I said it is going down, and therefore my kinetic friction appears upward. I will write mg sine theta minus mu n is equal to ma. And all of this is a new axis, new coordinate axis, inclined at 30 degrees. Okay, so this is one. And we know the normal reaction is how much? Mg sine theta minus mu k. I'm making it explicit, it is k into mg cos theta is equal to m, I'm writing m1 also, so that we know which body are we referring to. So this is what I will get. G sine theta minus mu g cos theta is equal to acceleration. So if you know the value of g, put it 9.8 into sine of 30 degrees minus kinetic frictional coefficient was given to be 0.3. So 0.3 multiplied by 9.8 into sine of 30 is equal to a. All right. So let's say this is 10. So 10 into sine of 30 degrees. 1 by 2 minus this is 10. So 30 into 1 by 2 is equal to a. Right. So this is 5 minus 15 is equal to a. A is equal to minus 10. So my assumption is wrong. The body will go up. It will not come down. Right. And then because we wrote all of this with the assumption that the body is moving leftward, whereas the body is showing negative, which means the body is going upward in this case. Tell me what happened to the kinetic friction if the body was moving upward. It will reverse its direction, right? I think the only mistake we have done is we should have written. So this is an incomplete solution. Let's complete it because you said we will do it with a tension. So mg sine theta minus mu n minus tension should have been written as ma. Look at the free body diagram carefully of the first mass, which is on the, if I want to show you that, what are the forces on it? This is mg sine theta, this is tension, and this is kinetic friction. So the net force is mg sine theta minus mu n minus tension is equal to ma. This is the way we should have solved it. We did a mistake. We forgot to write minus tension here. Second, okay, this is straightforward. There is no friction involvement. If it is going leftward, then it is going upward, which means the tension wins and M2G minus M2A. Let's calculate this now. So if we add them, we will get m1g sine theta. Tension will get cancelled. Minus mu n minus m2g, okay, is equal to m1 plus m2a. So we know the value of m1 is 5 into 10 into 1 by 2 minus 0.3 multiplied by mg cos theta, which we calculated as 15, right? So this, let's put it as 15 directly. And additional tension is already gone, and then we have m2g. What is the mass of the second body? 10 kgs. Okay, so 10 kgs. So 10 into 10 is equal to 10 plus 10, sorry, 5 and a. So this is 10 minus 15 minus 100 is equal to 15a. A is coming out to be minus 25 minus 75 by 15. Okay, so this is 15 fives are. Right? So we know that if we solve like this, the body is not going downwards. It's a reverse. So what do? You rewrite this as it going up t minus mu
अगर
n.
अपना एक्सेलरेशन नेगेटिव आ जाती तो मतलब बॉडी अपवर्ड जाएगी.
Wait. Don't conclude. Abhi dekho. Now it is upwards, right? Tension. And now if I assume the body goes upward, let us see what happens. Mu n minus mg sine theta is equal to m1a. And since this one is also going down, I have taken it to be upward now. Okay, instead of downward. Let us see what happens to acceleration sign. Okay, now look at this. So this is mg minus tension is equal to m1 2, sorry, this is 2a. Let's calculate. So what do you get? You get m2g minus mu n minus mg sine theta is equal to m1 plus m2a. What is m2g? 10 into 10. What is the normal? This 15. What was mg sine theta? 2. How much was this?
ये शायद 5 था.
Oh, 25 था यार ये. 2 5s are and 5 5s are 25. Anyway, so this will become how much?
सर ये नेगेटिव में आ जाएगा.
ये आ जाएगा 100 minus 15 minus 25 is equal to 10 plus 15 into a. How much is a coming out to be? 75 50. We can correct this also. ये भी 50 आता हमारा.
50 नहीं होगा सर. 25 minus 15 40 होता है.
अच्छा, okay, 60, right? 25a. So a is equal to 60 upon 25. ये भी वैल्यू वही आती. इधर हमने I think we did a mistake here, which is we should have taken this also to be 20 25. And I think we did a mistake here somewhere. mg sin theta and यहाँ भी हमने वही लिया देखो 10. ये भी 10 into 10 है. So 10 into 10 भी है हमारे पास. एक हमारे पास नॉर्मल रिएक्शन है. तो ये हो जाता 25 minus the so if you notice this particular case, right, the value of a is coming out to be positive. If you see the sign convention, right, because your coordinate axis which was here has undergone a change, right, by a translated by this much amount. You can notice if the body is going upward, it is x dash, and on this side it is x negative. So this is the answer is positive, the body is going upward. And in that case, in the upper case also we should have got the same value but with a negative sign. That's the only difference. We have done some error in the calculation. Otherwise negative would have told you reverse direction, because you assumed to be in this direction. It came opposite to what you thought. If you do a calculation again, what happens? mg sin theta is 5 tens are. So this should have been 25 then minus mu n, 0.3 into n, and what is, this is 15. So 25 minus 15 minus m2g, right? So m2 is 10 kgs. So what is the net force available to you in that? How did we get this? Acha nahi, we know the tension. Acha, tension 1 here. So we added an m1g minus mu n minus m2g is equal to m1. m1g is 25. 25 minus 15 is how much? Minus, it is 10. And minus 100 minus 90 is equal to, we're getting some value. And if we calculate the value, there's some टेंशन चला गया है, m1 प्लस m2 आ गया a, ये mg sin थीटा माइनस म्यू एन माइनस m2 g, हाँ ठीक है लिखा है यार, आई थिंक m1g was 5 kg, right? 5 into 10 into half, this is 25. Then mu n is 0.3 into mg cos theta. mg cos theta will be 5. Okay. What is mu n equal to? 0.3 multiplied by m, 5 into 10 is equal to 3 into 50 is equal to 15, which is correct. 15 newtons is also correct. This is a force which is going down, and this, when we add these, we get minus m2g and m1g sin theta minus 15. 25 minus 15 minus 100 is equal to this. So you're getting a as minus 90 is equal to 15a, and a is equal to 15 minus 6 meter per second square. Okay, calculation wise it appears to be correct, but only from calculation point of view. Okay, mu n, okay, and this comes out to be plus, right? Between the two, which one you think is correct? Value तो आ गई दोनों के अंदर, right? You do get a value, but which one is correct?
I guess पहले वाला ज़्यादा सही.
Okay, let's put the value. Let's put the value then. Let's look into the values also. हमने tension भी तो निकालनी है ना? So let's calculate the tension then. Okay, let's calculate the tension. That may give you a glimpse. Okay, so let me calculate tension from here. So it is going up. So T minus 10 into 9.8 is equal to M2A, right? It is going upwards, which is 10 into minus 6, right? So T minus 98 is equal to minus 60, and tension is equal to 98 minus 60 is equal to 38 newtons.
Okay.
38 newtons is the net tension in the body. Let's calculate the tension in the second scenario. If the body is going upward or downward, right? So we are now assuming the body is going upward. We found an acceleration. Let's find the same thing again. 10 into 9.8 minus 60, sorry, tension is equal to M2A, which is 10 into 60 by 25. So tension is equal to 98 minus 600 upon 25, right? 25 tens are 20, 24. So tension is equal to 98 to 24, right?
72. This 70.
Yes, whatever. Tension is this much. So tension is varying in both the cases, right? How much is the tension is actually deciding the fate. If this is too large, then this combined with mu n takes it upward. If it is too small, which is 38, then m1g sin theta wins, and these two lose the battle. So in the question, you are given this. Situation number 1, when the body is going up, and calculate the same thing when the body is going down. So two scenarios for kinetic friction. The friction is, which means you are going to decide the tendency of the body from some external source, which means you may apply an external force to start the motion or give it the tendency. Maybe you pulled it upwards once and then left it. You brought it in kinetic motion. So, the answer is not which one is right. Both are possible, depending on what was the initial tendency you gave it. If the initial tendency you've given it is upward, then the first part is correct. Sorry, the second part is correct, which means you pulled it down with some external force more than this. So T, if you adjust the T, I'm saying if you pull the T upwards with a force, then your situation number, this where we got a larger value, is true. So it depends what kinetic, which direction is friction acting. It depends. There is no hard and fast. If they don't tell you which direction is body moving, you will have to assume both to solve this. You can't decide unless they tell you what is the initial direction of the frictional force or the body was already in motion. ठीक है, तो स्ट्रिंग में द एडेड डिमेंशन ऑफ द स्ट्रिंग ब्रॉट इन कॉम्प्लेक्सिटी, नथिंग एल्स, और कुछ भी नहीं था इसके अंदर.
ठीक है.
Bit difficult type, not difficult exactly, difficult to imagine two scenarios for a string scenario, right? थोड़ा सा मुश्किल हो गया, नहीं तो wasn't that hard. Both the scenarios become true, but in the question they have to explicitly tell you what is they're asking for. Okay, let's go to one all NCERT, right? So this is your so let's say NCERT. I will bring up a question. Let's see you can relate to it to start with. Okay. NCERT announcement publication is 12th, 11th, and this is physics class 11th, chapter number 3. I'll paste a question and we will motion in, sorry, 4. Okay. You will also get, आपको स्कूल में वो करा दिया बैंकिंग ऑफ रोड्स?
नो सर.
नहीं कराया. जो जेई में आता सब एवरीथिंग इज बीइंग लेफ्ट. बुक में भी काट दिया इन्होंने. वियर्ड मैन. We'll pick up a question on our own and solve it. Okay, so that
ये रोड्स हम भी कर रहे हैं.
क्या कर रहे हैं?
बैंकिंग रोड्स.
हाँ, करना होता है यार. मतलब it's a pretty much part of syllabus. I don't know why मतलब why it was left out. Very strange. Very, very strange. Everything we are studying has been left out to. Okay, so this is straightforward. We have to look at tension in the string and okay, so let's not get into numerical first. Let's do something simple, okay? So that we straight away don't jump into. Okay, I will just discuss this question. Let me paste these. Okay, so let's talk about this. Fill in the blanks. Okay, definition only, nothing great. Choice number, question numbers first, second, third. हाँ जी, क्या आंसर है?
सर ये सी होना चाहिए.
Okay. Can you agreed? 18th.
सी सही है.
Yes, correct है.
एंड
Correct. Second.
सर बी होना चाहिए.
Okay, let's see that also. उल्टा बोल रहे हो यार.
एक मिनट.
I think you're talking about reverse, right?
सर काइनेटिक फ्रिक्शन एक्ट्स एंड ये बी होना चाहिए.
Correct. C.
सही है.
19th. अगला.
बी सही है ना.
हाँ हाँ ठीक है. ये तो डेफिनेशन है. ठीक है. नेक्स्ट. हाँ जी. नेक्स्ट. क्या आंसर है?
इट शुड बी सी.
No, I think kinetic friction is always less.
इट्स स्टैटिक.
C तो kinetic friction greater होता है. I don't think so. Coefficient of kinetic friction less छोटा होता है. Mu K is smaller than mu S. Static friction, शायद ग्राफ ये था ना इसका. You reach a threshold value. You reach a threshold value and then the kinetic friction reduces. So kinetic friction is always less.
Okay. So B.
B is also. B says because the two surfaces, when the two surfaces are in relative motion. Motion तो अभी start ही नहीं हुआ.
अच्छा. फिर D होगा.
Yes. This is an indirect way of saying kinetic friction. लिखा नहीं ना word kinetic, सिर्फ ये लिख दिया तब जब वो relative motion में होते हैं. So be very careful of the English they use can be tricky, right? Just read it carefully. Okay. So some of the values that you should know, okay, are very important. Are these. So that coefficient of friction is between two surfaces. Rubber on concrete, wood on wood. It's a relative between two. Steel on steel, something. You know, it's always relative. Steel on ice. You should know those two surfaces to comment on the coefficient of friction. It is not a constant quantity everywhere. It depends on what surfaces are involved.
Okay.
All right, let's continue to do very small problems. We've done large ones, but we will do very small ones first. Let's say you are doing this one. हाँ जी,
सर पहले वाले का तो बी होना चाहिए।
ओके, करेक्ट है।
देखो अगर हम वेक्टर्स की को रेजोल्यूशन करें
हम्म
तो वी साइन थीटा ये पैरेलल है इंक्लाइन के,
हम्म
शुड बी बी।
क्या आंसर है? अगले का क्या आंसर है? कैलकुलेट कर लो। ठीक है, टेक 10, यू कैन टेक 10 ऑल्सो, एंड वही आ गया जी साइन थीटा। ठीक है, करेक्ट है। आगे नेक्स्ट।
सही है ना?
ठीक है। अगला।
सर इसमें एम जी की डायरेक्शन रॉन्ग है सर।
एम जी तो परफेक्ट है। एम जी के तो कंपोनेंट बनाते हैं, एम जी साइन थीटा और एम जी कॉस थीटा। वेट तो हमेशा डाउनवर्ड होता है, कल ही तो डिस्कस करा था।
नहीं
कोई
नहीं,
फर्क नहीं पड़ता। यू गॉट टू गो बैक एंड रिवाइज द टॉपिक योर सेल्फ।
नहीं एम जी लाइक जिस तरीके से बना रहा है।
हाँ, बताओ क्या गलती है।
एफ क्या है वैसे कुछ
सम
एफ।
एक्सटर्नल फोर्स, सम एक्सटर्नल फोर्स।
एक तो मुझे इसमें एक फॉल्ट लग रही है,
हम्म
एक तो इसमें लग रही है और एक इसमें लग रही है।
ये तो नॉर्मल रिएक्शन तो लगना ही लगना है। आर
नहीं
इज अ
वो तो
नॉर्मल
ठीक है
रिएक्शन। हाँ,
नॉर्मल रिएक्शन, पर उसके लिए डायरेक्शन जिस तरीके से बना रखी है।
डायरेक्शन बिल्कुल ठीक बनाई है। इट शुड बी परपेंडिकुलर टू द सरफेस। मैं एम जी के दो कंपोनेंट ले लेता हूँ मैं। एक तो हमें मालूम ही है एम जी कॉस थीटा होगा,
हाँ जी।
साइन थीटा, और एक होगा एम जी कॉस थीटा। और आप इंक्लाइन प्लेन को प्रेस करोगे एम जी कॉस थीटा से, इंक्लाइन प्लेन आपको आर से करेगा। इसका मतलब मैग्नीट्यूड ऑफ आर इज इक्वल टू, बिल्कुल ठीक है, ऐसे ही बनाते हैं नॉर्मल रिएक्शन तो। नया नया सरफेस, उस पे परपेंडिकुलर। ओके, लेट मी आंसर दिस। ये दिख रहा है वर्ड, कांस्टेंट स्पीड।
ओके, फोर्स तो फिर लगेगी नहीं।
तो यहां मतलब एक फ्रिक्शनल फोर्स है विच इज इक्वल टू दिस काइनेटिक। तो बैलेंस्ड नहीं है ये।
ठीक है।
अब जाएगा ये कांस्टेंट उससे, वेलोसिटी से, क्योंकि नेट फोर्स अपवर्ड डाउनवर्ड इज बैलेंस्ड।
नेट
इसने
फोर्स जीरो हो जाएगा ना,
हाँ,
एक्सेलरेशन भी जीरो है।
यस, इक्विलिब्रियम टाइप ही हो गया ना, लेकिन इनर्शिया ऑफ मोशन तो रहेगा। You are pulling it with 5 Newton, then there is a 5 Newton here also. That is why the velocity can be constant. Otherwise, how can the velocity be constant? No way.
ओके।
Next.
टैफ्लॉन क्या होता है?
जैसे बेकलाइट वगैरह होता है, इलेक्ट्रिकल इक्विपमेंट का, टेफ्लॉन बहुत मजबूत होता है, प्लास्टिक टाइप का होता है। यू कैन रेफर टू द चार्ट एंड ये तो पक्का है कि शूज ऑन आइस तो ऑलरेडी स्लिपरी होता है, बिकॉज स्टैटिक फ्रिक्शन इतना कम है।
मेटल ऑन वुड का मुझे ज्यादा लग रहा है।
हाँ, मुझे भी लग रहा है, बट कह नहीं सकता मैं अभी, कांट गारंटी बिकॉज, बट शू ऑन द आइस is the least static friction.
सर इट्स मेटल ऑन वुड।
Okay. But what about A? A में क्या कैरेक्टरिस्टिक है? A में क्या होगा?
शूज ऑन आइस।
क्या होता है A के अंदर? रियल लाइफ के अंदर क्या होता है?
वैसे फिसलते हैं।
इसका मतलब स्टैटिक फ्रिक्शन बहुत कम है ना,
हाँ जी, फिसल जाते हैं ना।
फिसल जाते हैं। स्टैटिक फ्रिक्शन इज वेरी लो।
यस।
अगला।
सर इट्स द नॉर्मल फोर्स।
ओके,
48 में।
यस, करेक्ट है। नेक्स्ट।
सर द बॉक्स विल मूव।
हाँ जी।
बॉक्स मूव करेगा।
द कोफिशिएंट ऑफ स्टैटिक फ्रिक्शन इज 0.4। फ्लोर के ऊपर है तो नॉर्मल रिएक्शन कितना है, पहले तो वो बताओ।
सर नॉर्मल रिएक्शन है 50 अगर G10 ले तो।
ठीक है, और स्टैटिक फ्रिक्शन कितना अवेलेबल है?
सर स्टैटिक फ्रिक्शन अगर लाइक 50 इंटू 0.4।
20 हिल जाएगा, ठीक है।
20।
50th मेक सेंस।
नेट फोर्स 30 न्यूटन आ जाएगी।
ठीक है, इक्वल टू एम ए।
यस सर।
होल्ड ऑन, नो, वो नेट फोर्स निकालने के लिए म्यू के चाहिए आपको, क्योंकि आप स्टैटिक को ओवरकम करके काइनेटिक जोन में आ गए हो, तो वो वाला यूज करना है आपको कैलकुलेशन के लिए, वो दिया नहीं हुआ।
ओके।
समझ गए ना, वो कम होगा 0.4 से थोड़ा सा। नेक्स्ट।
बट मूव तो ऐसे भी करेगा ही।
मूव करेगा, ठीक है, अग्रीड, बट कैलकुलेशन वाइज व्हाट इज द एक्सटर्नल फोर्स वी डोंट नो, बिकॉज वी डोंट नो म्यू के। हमें सब्ट्रैक्ट म्यू के एन करना होता है ना कि म्यू एस एन।
तो 37 डिग्री इसको क्या लेंगे?
एक्चुअली दिस जो वैल्यू ये पूछ रहा है, वी हैव नॉट स्टडीड इट, इट इज कॉल्ड एज द कॉन्सेप्ट कि अगर आपके पास एक इंक्लाइन प्लेन है, उसमें जो आपका जिस एंगल पे आप इंक्लाइन का एंगल चेंज करते रहो, एक पर्टिकुलर एंगल पे द बॉडी विल स्टार्ट मूविंग। आप इंक्लाइन का एंगल बदलते जाओ, एक एंगल आएगा जहां पे यू विल अटेन द वैल्यू म्यू विल बी इक्वल टू tan ऑफ अल्फा, राइट? दैट टेंजेंट ऑफ अल्फा इज द if the coefficient of क्या निकालना क्या है, find the friction, right? You have to find mu k, so this will give you the highest value of the static friction. That is what it gives you. तो आप देखो इसमें tan 37 कितना होता है, 3/5.6।
एक बार चेक कर ले तो टेबल
और
में।
tan की वैल्यू देखनी पड़ेगी और देखना पड़ेगा कि मैक्सिमम स्टैटिक फ्रिक्शन कितना अवेलेबल है अपने पास।
tan 37 is 0.75।
ठीक है, डाल तो देख लो हाउ मच स्टैटिक फ्रिक्शन इज अवेलेबल टू यू एट दिस। सेल्फ एडजस्टिंग है तो मैक्सिमम कितना अवेलेबल है देख लो, 0.7 मल्टीप्लाई बाय एम जी कॉस थीटा, 0.75 इंटू 60 इंटू कॉस, तो इसका tan मालूम चल गया तो कॉस भी आ ही जाएगा, क्योंकि उस टाइम पे tan की वैल्यू जो है वो म्यू एस को रिफ्लेक्ट कर रही है। तो यू नो द वैल्यू ऑफ tan अल्फा की वैल्यू मालूम है, अगर इट इज 1.75 upon 1 which is perpendicular divided by base, then hypotenuse you can also find out, right? 0.75 square plus 1, so cos alpha will be equal to 1 base 0.75 divided by under root of 1 square plus 0.75 square. तो normal reaction जो आएगा that is equal to mg cos alpha। तो cos alpha हमने निकाल लिया, m हमें मालूम है, g भी मालूम है, तो हमें मालूम चल जाएगा what is the mu n available to us। static friction भी हमें मालूम है, ये मालूम है coefficient of static friction, सॉरी k मालूम है, mu k is equal to 0.01, और एक अल्फा भी दे रखा है, we have to link tan alpha, sorry, what you can do now is you can okay, sorry, I have not told it to you correctly. What you have to do is, since you have found out the angle, just calculate the value of mg sin alpha available to you. That means you have to find mu k, right? Mu n, mu mg cos alpha. So you have found out tan alpha?
यस सर।
जी दिया ना 37 डिग्री, तो ये cos alpha निकालने में मदद करेगा ना ये।
यस।
और आगे आपका फ्रिक्शन। सो मैंने जो आपको कॉन्सेप्ट बताया था वो डिफरेंट कॉन्सेप्ट है, दैट इज समथिंग एल्स विच आई टोल्ड यू, जो टेंजेंट से मैं लिंक कर रहा था, दैट इज अ एंगल ऑफ फ्रिक्शन आई वाज रेफरिंग टू, वेयर द inclined is moved and at certain angle the body starts moving. Okay, that is called angle of friction.
एंगल ऑफ
Friction, that is called angle of friction, and तो मतलब उसमें you are changing the value of the angle of the incline.
इंक्लाइनेशन वाला एंगल होता है, इसको भी कुछ कहते हैं ना?
हाँ यही है ना वो, the angle of friction. Normal reaction, हाँ नहीं नहीं एक मिनट, hold on, क्या वो, come again, repeat what you're saying.
एंगल ऑफ रिपोज।
हाँ वही बता रहा हूँ मैं आपको, जो मैक्सिमम एंगल पे जब आपको अगर एक इंक्लाइन प्लेन दे रखा है और इस समय बॉडी यहाँ पे रुकी हुई है, राइट, थीटा पे स्टैटिक चल रहा है अभी भी, आप इसको एंगल को बढ़ा के एक ऐसे एंगल पे ले आओ इंक्लाइन को कि बॉडी चल पड़े थोड़ी सी, तो वो उससे थोड़ा पहले जो एंगल होगा अल्फा, उसका अगर tan अल्फा करोगे तो वो आपका स्टैटिक फ्रिक्शन के बराबर ही आएगा कोफिशिएंट के। तो मैं इस क्वेश्चन में गलती से वो निकाल रहा था कि मैक्सिमम स्टैटिक फ्रिक्शन कितना अवेलेबल है, इसने वो पूछा ही नहीं था, इसने सीधा पूछा व्हाट इज द फ्रिक्शन। तो मैं एक्चुअली एंगल ऑफ रिपोज या इससे आई वाज ट्राइंग टू फाइंड आउट हाउ मच इज द स्टैटिक फ्रिक्शन अवेलेबल। तो मैं क्या कर रहा था, मेरा जो mg साइन थीटा है वो निकालता मैं, फिर tan 37 को गलती से मैंने एंगल ऑफ रिपोज या एंगल ऑफ फ्रिक्शन मान लिया था। तो मैं एक्चुअली देख रहा था कि mg sin थीटा और म्यू एस n में से बड़ा कौन है। अगर mg sin थीटा is bigger than tan alpha into n, because tan alpha is nothing but the static friction coefficient between the two surfaces, which is used to calculate the maximum static friction. अगर mg sin थीटा tan alpha into n से बड़ा हो गया तो ये बॉडी चल पड़ेगी। तो मैं अपना फ्रिक्शनल फोर्स निकालने के लिए क्या यूज करूंगा, म्यू के इंटू एन। वो मुझसे पूछा है इन्होंने वो एंगल ऑफ रिपोज नहीं दिया हुआ था। इट वॉज नॉट मेंशन दैट द एंगल ऑफ रिपोज और फ्रिक्शन एंगल इज 67। क्वेश्चन में दिया कहां पे हुआ है, नहीं दिया ना, कि इस इंक्लाइन का माने इन दो सरफेसेस का एंगल ऑफ फ्रिक्शन 37 डिग्री है। वो दिया ही कहां था। इन्होंने तो बोलता है एक बंदा जा रहा है 37 डिग्री पे, अब बताओ उसके ऊपर कोफिशिएंट वो चल रहा है ऑलरेडी, ही स्लाइडिंग, देन टेल अस व्हाट इज द frictional force acting on it. If he's going down because he's he's into skiing, so the frictional force mu k is n. So we know the value of 0.07 multiplied by mg cos theta. Theta is also known to us from the value of alpha. So we can go and check that what is the value of cos alpha, and we can substitute here into, मतलब ये आ जाएगा 0.07 multiplied by 67 into 9.8 into cos of 0.75 divided by under root of. This is the frictional force, but it is kinetic in nature. If they had mentioned the angle of repose or the frictional angle is 37 degrees, then I would have taken this into account. कि अब ये हिलेगा 37 डिग्री के बियॉन्ड हिल जाता है। पहले तो मैं वो चेक करता कि मेरे पास उतनी ये अवेलेबल है भी कि नहीं है, कि मैं आई कैन बीट द मैक्सिमम अवेलेबल स्टैटिक फ्रिक्शन। सही है?
Yes, sir.
Got it ना? ठीक है। So what you do is please do some questions on friction. I am sending you an assignment on friction. I am sending you an assignment of linear momentum. दो टॉपिक हमने कवर कर लिए। Of course हमने inclined plane पे, you don't have to worry about the thread वाला. We will come back to that. Just do some numericals on law of conservation of momentum. I will send you some MCQs now, and then please revise yourself. So in nutshell, what we have done today, we got introduced to the idea of collision. There are multiple types of collisions, and the one which is the most observable is the inelastic. There's a loss of energy. We studied a special type of law of conservation of linear momentum in which the energy also came into picture. So that was called as collision. 3 cases for that. Depending on kinetic energy is lost, remains same or increases. And then to represent that mathematically, the concept of coefficient of restitution also came in. The coefficient of restitution is the ratio of the velocities only. And if it is 1, it is 100% kinetic friction. Sorry, it's 100% case of law of conservation of kinetic energy also getting applied apart from law of conservation of momentum. Then we saw some cases in the elastic head-on collisions where the 2 masses were equal, 1 mass was too large. Then we went to study what is the difference between kinetic and static. We have done some questions on it. And I think broadly you have understood how to do resolution and all that. We will bring all of this together in some advanced level problems, but please do those MCQs which I send you. इससे आपका हाथ थोड़ा शार्प हो जाएगा करते हुए। ध्यान रखोगे आपकी स्टैटिक है।
बच्चे इस पे
हैं?
कितने टॉपिक्स और बच्चे?
एनसीईआरटी के हिसाब से तो कुछ नहीं बचा, बट जेई मेंस के हिसाब तो यार बहुत कुछ बच गया। आई मीन बैंकिंग ऑफ कर्व है।
केम का पेपर सिर्फ 4 अगस्त को है।
ओके, वी कैन डू दैट फर्स्ट है। उसमें क्या क्या आ रहा है?
केमिकल बॉन्डिंग एंड
ठीक है, देन वी विल नीड 2-3 long sessions to complete it, क्योंकि I may teach you but you need time to digest it. स्कूल में कुछ कराया उन्होंने, कुछ समझ आ गया?
कुछ आया, कुछ नहीं आया।
ठीक है, we will discuss it. Then we will not go to JEE mains and JEE advanced for that. We will stick our conversation strictly to your school level. ठीक है? We will not go beyond that. कोई फायदा नहीं होगा अभी। उसमें कई ऐसे टॉपिक्स हैं, बहुत लंबे टॉपिक्स हैं उसके अंदर जो कवर नहीं कर पाएंगे हम स्कूल के पेपर के लिए। ठीक है जी, तो लेट्स मीट टुमारो एंड स्टार्ट केमिस्ट्री देन।